Sass class with Amanda. Hey! In this video, we'll begin talking about scatterplots and correlation. Our learning objectives are to define what an explanatory and response variable are and to show how we can graphically represent the relationship between these two variables. We'll start with a simple example. Everybody knows the quote, "The bigger they are, the harder they fall." So we have 5 different objects with different weights in kilogram and the force with which they hit the ground, when we are taking into consideration that there is air resistance. The definition of explanatory and response variables, we can use these variables to explain. So the bigger they are, the harder they fall. There's sort of an inherent hypothesis here where the more something weighs, the harder it'll hit the ground. So that tells us that the explanatory variable is the weight. Weight is the explanatory variable. The reason why this is the explanatory variable is because it explains the force, because it explains the response or the outcome, or it explains the outcome of the experiment. So that implies that the force is the response variable. So the first thing to note is that we're talking about the relationship between 2 quantitative variables, okay? These are 2 different variables and they're both quantitative. We want to know their relationship to one another. So our hypothesis was that weight explains force, okay? What you would do is gather some data based off of the experiment, and we have our data. So a typical XY graph is a scatterplot. Just a few things to note is that the variables need to be measured on the same individuals. Variable measurements, so we're talking about force and weight. Need to be on the same individuals. So in our data set, each individual is an object, okay, and our 2 variables are weight and force. So that means if we drop a bowling ball, for example, then we're measuring both the weight and the force of that bowling ball, and that becomes our object. And you let each point on your graph represent that object. And that's our second point, is that each point or each individual appears as a point on the graph. Each individual appears as a point on the graph. The reason that I'm writing all of this out is so that you have it in your notes for later. So you do have some room down here to draw the graph. I'm going to draw it on the side here so that we can see the data while we're creating the graph. So there will be an X and Y axis, or an explanatory and response axis, where this is our weight in kilograms, and this is our force in kilograms times meters per second squared. You should always write out your units depending on what your axis labels are. Okay? Alright, so our minimum weight looks to be 0.91, so we'll start at 0, and our maximum weight should be 50, so maybe we'll move up by tens. So 10, 20, 30, and however you scale this axis is up to you. These are just what I'm choosing. Alright, In force, the minimum force looks to be about 8. So I will have a minimum of 10. And the maximum force is 443. Actually, I'm going to make this a 100, and then 200, and then 300, and 400, and then 500. Alright, so we want to plot each of these. So 45.3, we find where that is. It's
approximately here. We go up to 443. Okay? So then our data point, our first data point, would be up here. Our next data point is 22.6, comma, 221.48. So 22 is approximately here. Go up to 221, which is approximately here. Alright, 34.5. Now that's, right about here in the middle. And then 338 is approximately here. And then 0.91 is all the way over here. So this is the lowest data point. And then finally we have a 38.6 all the way up to 378, which is close to 400. So it looks like that. Don't forget to give your graph a meaningful title.
I'm literally going to steal that quote. The bigger they are, the harder they fall. Okay, so a scatter plot is just the graphs that you are most comfortable with. You have an explanatory variable or independent variable, and then you have your response variable or your dependent variable.
My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. We live in a world of technology. They're collecting information on your humanity. Social networks, gaming, and in-home software.
Hello, Alexa.
Statistics helps us be more aware. Haters gonna hate my spicy lyrics. Why you gotta be so mean? Pulling me towards your extreme moods, but the median never fails to center me. 50 to my left, 50 to my right. Got these correlation and regression tools, forget them fools. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. The mean of the means is the mean. The mean of the means is the mean. The mean of the means is the mean is the mean of the means is the mean is the mean. Be careful not to fall in love. Statistical seduction from above. Your shape so beautifully symmetric to the eye with a single peak so high. I hypothesize and can testify that your p-value is the smallest I've seen. Mix that with a large power and I reach ecstasy. Your residuals defy the rest. A small scale randomized pattern tells me you are the best fit. My name is Llama, and I'm here to teach you stats, skilling you up with the cold hard facts. My confidence is so high, 95%. My margin of error so nil, 110. Can you feel me? Can you feel me? I estimate your population parameter based on only one sampling. Oh, haven't the frequentists told you about me? We live in a world of data, attempting to understand life by statistical strife. The implicit bias of cops, success rate of them jocks, medical advances, and AI romances. Statistics.